And welcome back. As we go ahead and jump into yet another programming lesson, let's go ahead and this time discuss anonymous objects. So in order for us to have this conversation about what an anonymous object is and how we might use it, we first need to discuss the new keyword. Consider expressions such as the following, using the toy class. If we say toy class variable 1 equals new toy class Joe, 42. The portion new toy class Joe 42 is an invocation of a constructor, that constructor of course belonging to the toy class. We can think of the constructor as returning a reference to a location in memory of the object that's now been created by this constructor. And therefore we can kind of extend it to almost say like, the equal sign in this line of code here is just an assignment operator. We're setting it equal to something. So just like how we would do the same thing with like ints, doubles, etc. So with the new operator, there are times when we want to create an object using new and then use that object as an argument to a method, but then never again use that object. And we pretty much, it's a one and done kind of sort of deal. In these cases, we don't actually need to give the variable name to that object. So we don't have to call a object, an object, or anything like that. We can actually just use the properties of that object. So what we can do is instead of trying to create another variable and work with it, we can actually just create an expression with the new operator and the constructor, therefore, directly as the argument. So let's learn this as a scenario. Suppose you want to test to see whether the object in variable 1 is equal to an object with the same number and with the same name, all spelled in uppercase. So let's look at this with two cases of equivalent code. So our first case is as follows. We say if variable 1 equals new toy class Joe, 42, system out of println equal, else system out of println not equal. This code, you'll notice, is equivalent. All right, and this is how we might have approached it up to this point. Toy class temp equals new toy class Joe 42 if variable 1 dot equals temp, system out of println equal, else system out of println not equal. You'll notice they are exactly the same, except we do have one more line of code right here, which is holding on to that value in this temp object. Here, there is no temp object created. So this gets us really to looking at how we are using those parameters for really that kind of comparison here. So in the second version, which of course had our temp variable in it, we create an object, and then that object, once it's created, is passed into the variable temp. Temp is then plugged in for the parameter within the equals method. But all the parameter passing mechanism does is to take the reference stored in temp and then plug it into the parameter for equals. That first version, if you notice, kind of simplified things a little bit. It created the reference to the object and directly plugs into the parameter in equals. It bypasses the variable temp, but ends up plugging in the same reference as the argument to equals. So this is going to get us to what we call an anonymous object. When you are not taking something and assigning it to a variable, an expression such as toy class Joe, 42 is known as an anonymous object. So notice, again, new toy class Joe 42. Are we setting it equal to a variable? No. And because it's not equal to a variable, it's therefore considered to be an anonymous object. What this will do then is it will evaluate a reference to an object of the class. And the reason why we call it anonymous is because, again, as I mentioned, that object is not assigned to a variable to serve as a name. There's no variable temp here or a variable or anything like that. Now, you might say, well, when am I going to encounter this? Well, this actually might be something you encounter in some various situations where the use of such an anonymous object is actually pretty common. You need to just pass in some object type parameters and you need to evaluate it. And so I want to wrap this up by coming back to this screen here. One of the things, of course, that we notice with this screen here is, again, the code does the exact same thing. If you were to take both of these codes, plug it into Eclipse, and say, what's the difference? Functionally, they are going to be the same. The only difference is that this is using an anonymous object here, because we're not setting it to a variable name, but here we are setting it to a variable. So that's just something important to keep in mind here. It's really not that much different for how we might go about creating an anonymous object, because again, as you can see here from this very simple example, there's nothing crazy new that we have to learn or to demonstrate. In fact, if you is like, I don't really believe you, how do I contest this? Go ahead and just take this code here that you see on the screen right now. Go ahead and take that toy class that we've looked at previously, plug your code in, do a if block like you see here for the first one, do an if block for the second one. You should, of course, see the exact same output because these are going to evaluate the same. Even if I use a different function, if I did, instead of like the equals method, if I did, let's say, a toString method, these should again still return similar values, if not actually equivalent values, not just similar, because remember the anonymous object is in a way simplifying what we do here with a temp.